Hello students, today in electrostatics we are discussing about the force concept problem based, that is mains level, and some advanced level questions problems we'll discuss. Before the one of the concept we are going to discuss here. What is the concept is, we taken two pith balls, these are called pith balls, PITC, pith balls, or otherwise you can take a small spheres also. Now what we given is, we given the charge to these two spheres. When you given the charge to these pith balls, what happens is, whenever they are suspended using a single support here, vertical support using rigid support here, whenever suspended side by side, then what happens is positive repulse each other. Due to the repulsion, they try to get separated from each other. So due to that separation, what happens, these okay uh, two pith balls will be get separated by certain distance. These two will be get separated by certain distance. So the distance of separation will be like this. Due to the repulsion here, the separation will takes place like this. Just a minute. They'll separate like this. Separate like this. In this case, the what is the direction of the force of repulsion? If you are indicating that direction of the force of repulsion, these two are going to be repelled in this direction. This is one, and this sphere will be repelled in this direction. Both are going to be repelled. So when they are repulsing each other, what happens? These two pith balls makes a certain angle with the vertical. So here what is happens, when they are repelling, they have to go separate away. But what is happens when they are getting separated? So certain concepts are going to be involved. That is nothing but we are calling as certain concepts will be involved here. One is weight of the body, that is nothing but mg we can write. Second one is electrostatic force of repulsion is going to act, that is in this direction, that is F, electrostatic force. Now due to electrostatic force, these two pith balls trying to separate each other, but due to weight, what is happens, as they are getting separated, weight is also going to act. That's why what happens at one of the position, this pair, the charges pairs will come into equilibrium condition. At that equilibrium condition, how much angle it is making? It is making an angle theta. Yes. The separation between these two, I can write as x between these two. So here, if you want to write the formula, in this case, here electrostatic force between these two charges I can write as Fe is equal to, so 1 by 4 pi epsilon naught into both the charges, that is, if you say both are q1 q2, like I am taking q1 q2 by distance. What is the distance of separation? X. If you say x square is the formula for this. This is the way I can write here, electrostatic force. Now if you, this is the one of the case when it is performed on the surface of the earth, due to gravity, the weight of the pith balls or spheres also effective in this case. That's why they are at one of the condition equilibrium. We'll discuss detailedly once again. Now come to the case of second condition. What this second condition? The same arrangement of the two pith balls, if you take it into the space, if you take it into the space where there is no gravity, in this case what is happens, this mg will not be effective. So because there is no gravity, that's why what happens, these two will be repulse each other such a way that both will be separated by an angle of 180 degrees. That means this is the positive charge, this is a positive, both will be aligned in a straight line, by making an angle 180 with the center. So in this case, what is the condition here? It is in the space, there is no weight component is taking place. So using these parameters, we have certain concepts are there. On the surface of the earth, we can, using the concept of this equilibrium, we are calculating some dielectric constant of the liquids. We can able to calculate that. Method of problems we are going to discuss now. Now we will write some relations in the case of a pith ball. When there are two pith balls are suspended from each other, when they are at equilibrium condition, we will have some relations. Using that one, we can calculate some required okay dielectric constant of a given liquids can be done experimentally. So in this case, what I'm doing is I taken two pith balls here, both are separated, okay, from the same point of suspension. So both when they given similar charge, what happens, repels each other. Now due to the repulsion, they separated a certain distance. So when they are separated, what is happens at this point? So at this equilibrium condition, now it is in equilibrium condition. If we say this with ball, at that moment here it makes a certain angle. This is the discussion we said. Now I am taking some parameters here. I taken, okay, the pith ball by suspending using a non-conducting wire of length L, right? And the spheres which you taken having, that is the pith ball which is having mass m, the charge on this one which is given is small q. Now when at equilibrium condition, why they are getting equilibrium condition? Because already we discussed, so both are positive, that's why repels each other. So this sphere is going to repulse the this sphere in this direction. This is the way the repulsion force is going to act. This force is called as electrostatic force of repulsion, Fe. Next, according to the concept of gravity, this is we are doing in the experiment on the earth. So there is a gravitation force is going to act on the body. So this is the way direction of the weight is going to act downward direction. Now here two forces are acting, Fe and Mg. At the same time, this is the string, and you know that along the string there is a tension is there. Here the problems we are doing by considering the string as a massless string. So in this case, I can indicate the direction of the tension in the string in this direction. So here on this body, how many forces are acting? Three forces are acting. And in the vectors, maybe you learned, according to Lami's theorem, whenever the body is in equilibrium under the three forces, you can apply the Lami's theorem, and that equilibrium condition, okay, so these forces may be surrounded by certain angles. In this case, tension is one force, F is another force, Mg is another force. So the questions may be asked in many ways. Okay, in this case, they can ask the what is the charge on the sphere, they can ask how many number of electrons present in the sphere, they can ask what is the angular separation of this, okay, sphere from the mean position, they can ask this, okay, mean position. And they can ask the what is the separation between these two charges. If you say x, what is the x value, they can ask. And what is the length of this suspension, how much length this, okay, pith balls are suspended, if they can ask. And the tension, the string, electrostatic force, weight, like that many questions can be asked in the single concept. That's why it is used in the mains and advanced level concepts. So in this case, to understand here, first, already at equilibrium condition, we found three forces here, right? Three forces. So under the condition of equilibrium condition, so what I can write here to solve this one, what I'm doing here, I taken coordinate system from this point. I taken the coordinate system, okay, from this point. This is the way I'm taking the coordinate system, that is y-axis, and I'm taking the coordinate system along y-axis also, x-axis and y-axis. If we take on the coordinate system, with respect to coordinate system, if you observe this one, now this pith ball, how much angle it is making? Theta. So according to geometry, I can take it as opposite angle also, theta. So here the tension T is making an angle theta with this vertical line. This dashes line, vertical line is making an angle theta. So if you resolve the T into components, so theta side always you'll get cos common, that is T cos theta is one component you are going to get, and second component you are going to get in this direction, that is T sin theta you are going to get. So I can resolve the T into using the coordinate system, T cos theta, T sin theta. Now if you see the diagram here at equilibrium condition, equilibrium means what? Horizontal equilibrium, vertical equilibrium. According to horizontal equilibrium, the electrostatic force of repulsion between these two is balanced by T sin theta, because these two are pulled away like this, and the T sin theta is balancing that. That's why it is in equilibrium. Similarly, the weight of the body with ball is balanced by T cos theta. So these are the two formulas most important to understand. Okay, electrostatic force Fe is balanced by T sin theta, and the weight of the pith ball is balanced by T cos theta. Now, by using the different methods of mathematical approach, we can find the relations. First, what you do is divide these two equations. If you divide these two equations, what I can write, sin theta by cos theta is tan theta. So I can write the relation here. Tan theta is equal to nothing but Fe by mg. So this is one of the relation we are going to use. So at equilibrium condition, theta is the angle made by this one. Theta is the angle made by this one. This theta also I can write in many forms. What way I can write? Tan theta is equal to, from this triangle. From this triangle, from here to here, what is that? From here to here is the length of the pendulum. Already we discussed. This is the length of the pendulum. This is here. Now from here to here, what is this one? I'm taking in red color. So from here to here, what is this one? This is nothing but x by 2, half of the distance of separation between these two. Now our requirement is tan theta. What is tan theta? Opposite by adjacent. Which is opposite? This is theta. If you say this is opposite, and which is adjacent, this becomes adjacent. So that means if you use the Pythagoras theorem, this is L, this is x by 2 means this value y. If you say this is as a y, what the y value will becomes? Using this triangle, okay, of this one, the 3 dots I'm keeping here, using this triangle, I can apply the Pythagoras theorem here. Using the Pythagoras theorem, I can write L square is equal to y square plus x by 2 whole square. So from this, y square is equal to what I can write, that is nothing but L square minus x square by 4x. So y is equal to under root of that. So in this case, tan theta is equal to opposite, that is nothing but theta opposite is x by 2, that is nothing but I can write as x by 2 by, okay, by adjacent. What is adjacent? Y value. What is y value? That y value is equal to, we can write as under root of, that is L square minus x square by 4. This is the one of the relation we can write in terms of tan theta. But this tan theta is very, very small angle. Okay, when the theta is very small, almost you can take it as, okay, sin theta. The theta, tan theta value almost you can take it as sin theta. If you take it as sin theta, that becomes opposite by hypotenuse, that is x by 2 by L also we can write. So this tan theta is almost equal to, tan theta is almost equal to, if you take it as sin theta, I can replace this, okay, sin theta. That means this sin theta is equal to, from this diagram, I can write that is opposite is x by 2 by L, I can write. So sin theta is equal to x by 2L. So theta is equal to, we can write simply x by 2L also, because sin theta is equal to almost these 2 is equal to theta. So based on this. So this is one of the relations we can write here. So up to here we done now. Up to now. So theta is equal to, simply I can write x by 2L, tan theta is equal to Fe by mg, and these are relations. Now to get the some more relations, what you can do is simply you take the, okay, both dividing equation, t is getting cancelled, right? So if you taken the concept of squaring and adding of these two, squaring and adding of these two, if you square this one, it becomes Fe square plus mg square is equal to, if you square this one, t square sin square theta, if you square this one, t square cos square theta. So t square, if you take in common, it becomes sin square theta plus cos square theta. According to trigonometry, what is sin square theta plus cos square theta? That is 1. So I can replace here, t square is equal to, because this total will becomes 1 into anything, that is same thing. So t square is equal to, I can write as Fe square plus mg whole square. So what is T? T is called tension the string. Tension the string is equal to nothing but Fe square plus mg whole square. This is the one of the relation we got in terms of tension in the string. So we got the theta value. If the question is asked based on theta, you can calculate two ways. This is the one, this is the one. And if they're asking tension, you can calculate using this one. Now here, what is the formula for understanding of this Fe? The Fe formula, what is Fe? Fe is equal to 1 by 4 pi epsilon naught. One charge is Q1, second charge is Q2. Q1, Q2 by R square. Here x is the distance we taken in the diagram. X square is the distance between the two charges. Okay. This way you are going to write the certain relations for problems. Now look at the problem. Similar to this question is given in the 2 times in the most important competitive examination. One is UK 1998 and IIT 1976 question. That's why this concept is important for us to understand very clearly. So what is given? Two identical charged spheres are suspended by strings of equal length. So same like what we discussed just now. We taken two spheres, we suspended, and after suspension, the strings makes an angle 30 degrees with each other. So here they are making an angle how much? 30 degrees with each other. Two spheres we suspended, and both are supported by an angle of 30 degrees with each other. So each other when suspended in liquid density, that means this is actually normally when you taken, this is the air is the medium here. When both are suspended in air, this is the way they are going to be separated, and this is the 30 degrees separation. Now the same experiment, that means the same two phase spheres we suspended in the liquid. Okay, in the liquid, in this case what they said, whenever it is suspended in the liquid of density how much? 800. Okay, that is 800 kg per meter cube density liquid if you taken. That means this is the liquid. If you say inside the liquid, if you suspended this system, in this case it is under the angle remains the same. This is most important point to understand. The angle remains same means what is the before angle? 30. Now also the angle will be remains 30. So under the same angular separation in air and in the case of liquid density, okay, here liquid density you can take it as sigma is equal to 800, okay, kg per meter cube I can write. Density of the liquid is given. And okay, so angular separation is same. Now what is the dielectric constant of the liquid? That means this is the liquid which is having dielectric constant K. According to electrostatics, dielectric constant also called as relative permittivity. So relative permittivity have a different okay definitions we have. So in this case to okay, before that we'll complete the question. So dielectric constant they are asking to find. Next, the density of the material of the sphere is how much? Sorry, given is 1600 kg per meter. This is the spheres which are a solid one, right? So it is having density. The density of this one is equal to nothing but we can write as rho. Rho is equal to how much? 1600 kg per meter. So density of the solid is given, density of the liquid is given. They are asking to find what is the dielectric constant of the K. Dielectric constant K also called as what I said. K also called as relative permittivity. So relative permittivity also we can write in terms of concept of force, because two spheres are experiencing a force. Here the force between the two charges in air. Here the force between two charges in liquid, Fl. So I can write here the ratio of force between the two charges in air by any medium is called as relative permittivity. So this is nothing but called as dielectric constant. So to get the K value, Fa by Fl value, if you calculate automatically, you get the K value in this question. Now in the case of when two spheres are suspended in air, separation is 30 already given at equilibrium condition. At that moment, if you taken the origin position, okay, original position from mean position, now the spheres are displaced through certain distance. That distance you can take as x here from the origin. Now here you know that weight of the body is always acts vertically downwards, and there is electrostatic repulsion is going to act away from this one, right? This electrostatic force is acting in air, that's why I can take it as Fa here. So our requirement is to calculate Fa as per our just previous discussion, right? Now there is a tension is going to act in this. So you know the concept of here. What is the concept here? T sine theta. T sine theta is balanced by Fe. Yes or no? That is nothing but Fe. T sine theta. Well, now what is theta here? This is the theta value. Total 30 means this becomes 15 degrees. So here I can write as this is T sine 15 degrees is equal to Fe, force between the two charges in air. That is, now what is mg? Mg is equal to, that is okay, balanced by T cos theta, that is T cos 15 degrees. So using these two we have a relation also, that is nothing but tan theta. Tan theta is equal to nothing but, that is force between the two charges in air by weight of the body, that is mg. So I can write as Fa by weight W in air, that is. Now theta is equal to how much? 15 degrees. This is tan theta, that is nothing but tan 15 degrees is equal to force between two charges in air by W. Equation number 1. Similarly, now the same setup we immersed in the liquid. The same setup whenever you take them inside the liquid, what is same? The angle between them is same. So that means from the main position, the angle is again 15 degrees, same angle of separation is same, but only thing is what is changes? Force changes. Force between the two spheres changes, that is electrostatic force. In liquid is different, weight is also different, that becomes mg dash. Why weight is different? Whenever any body immersed inside the liquid, due to buoyancy, the weight of the body changes. That means the apparent weight of the body will be, okay, takes apparent weight of the body will be different in the liquid, right? Actual weight is different, and in the liquid, the whatever the weight you are measuring, that is called apparent weight. So in this case, I can write using the same formula. Under equilibrium condition, tan 15 degrees is equal to nothing but force between the two charges is force in the liquid, FL, by weight of the body is W. Okay, WL I can take, not A. You can take it as W. This is equation number 2. So both are equal, they said. So you take the relation here, that is nothing but FA by weight of the body in air is equal to FL by weight of the body, okay, in liquid. So our requirement is what? Dielectric constant K. Simply the dielectric constant K is equal to what I can write? K is equal to, that is called relative permittivity, also called as force between the two charges in air by force between two charges in liquid, FA by FL. So from this, what is FA by FL? FL make this side, the okay, weight of the body in air, make that side becomes weight of the body in air by weight of the body in liquid becomes. So what is weight of the body in air? So here K is equal to weight of the body in air is equal to nothing but mg. Now weight of the body in liquid, that is called apparent weight. Apparent weight always less than the actual weight because some amount of weight is going to be losses. That weight we can write in terms of like, so we have to go to the, okay, liquid concept. Okay, in that case, what is apparent weight? Apparent weight is equal to actual weight minus force of buoyancy. Apparent weight of a body is equal to, inside the liquid, is equal to actual weight minus force of buoyancy. So what is force of buoyancy? Actual weight minus force of buoyancy always applied by the liquids. That's why volume of the body, density of the liquid into gravity you take. So in this case, what is this m, mass of the body? Mass of the body I can write as volume of the body and the density of the, okay, body and gravity minus volume of the body into density of the liquid. In this case, density of the liquid I taken as sigma into G. So if you taken here Vp, okay, into G into rho P, if you taken common here, that becomes 1 minus I can write as sigma by rho I can write. So this is nothing but actual weight. Okay, this is nothing but actual weight. Apparent weight is equal to, okay, so I can write apparent weight is equal to actual weight, that is nothing but mg into 1 minus sigma by rho I can write. So this apparent weight is nothing but called as WL. So nothing but this apparent weight is equal to, I can write, if you want to write in formula, weight of the body in air by, okay, apparent weight of the body, apparent weight we can write. So what is apparent weight formula? That is mg into 1 minus sigma by rho is a formula for this. Now this mg get cancelled, so k is equal to nothing but, okay, 1 by 1 minus sigma by rho. What is sigma value? Already in the question they given very clearly, liquid density is 800 is given and the solid density is given 1600 is given. So if you calculate this one, how much you are going to get? 1 by 2 you are going to get. So if you calculate this value, 1 by 1 minus 1 by 2 you will get. So nothing but 1 by 2. 1 by 2 means the 2 will goes up, k value is equal to 2 you are going to get. So whatever the liquid you are using, where the angular separation is same, under the condition, what is the dielectric constant of that liquid given, we will get as k is equal to 2. So this is the answer for your question in this. This is asked in the previous root K and IIT, okay, advanced level question in the previous year's competition. So this concept is most important to understand because multiple concepts are involved in this question. This question also one of the previously, okay, discussed concept based problem, suspended, okay, uh, charged bodies and repulsion and equilibrium condition based question. This is asked in the previous mains and some competitive examination question. Numerical based we are solving the question now. What is given here? Two small metal spheres, having equal charge and mass, suspended from same point, some point of ceiling of damp roof, and with a silk thread of length. Center to center distance between spheres is x. So I am taking the diagram here. This is the way we are taking the diagram. Two spheres we taken here. One is suspended, okay, and both are suspended from the same position. Initially they are here. Initially they are here. Now both are separated by certain distance. How much distance are separation? X. So the separation between these two is given as x at equilibrium condition. L is the length of the silk thread. L is the length of this thread which you taken to suspend the spheres. Due to ionization of medium, charge leaks off from each sphere. So here what is happening? The charge, it is contains the charge Q. This charge is leaking out time to time, okay, and keeps coming closer each other with a constant rate. That means whenever the charge is coming out, what happens when the charge is coming out? The force of repulsion between these two will be changes. Due to that, what happens? Force of repulsion changes, automatically both will approaches towards each other with a certain velocity. Yes or no? So because how much, what is the way the charges are more, okay, disappearing? That means ionization takes place. More the rate of charge is okay going out, more the speed it acquires. So that means that we are calling as dq by dt. Rate of flow of charge is called as dq by dt. So this, basing on dq by dt, the speed of the charges which are coming towards each other depends. That is a given here. Let their approach velocity v varies proportional to x power minus 1 by 2. That means what the speed they are coming with the proportionality of x power minus 1 by 2 relation they given. Now, if the mass of the each sphere is m, then rate at which the charge varies with respect to time. So, dq by dt, this is the loss of charge, which is leaking of charge. Due to this one, the spheres are gaining the velocity towards each other. They are moving towards each other in the place of repulsion. They are trying to move towards each other with a velocity relation. This is given. So, what question they are asking? dq by dt, the rate of flow of discharge is proportional to, not equal to, they given basing on proportionality. So we have to eliminate some things. Okay, proportional to n by 2 into under root of 2 pi epsilon naught into mg by L relation is given. So to what is the n value they are asking to find? N is equal to how much? To find the n value, first you have to understand the concept here. So what is the concept here? Both are separated by a certain angle. So in this equilibrium condition, with respect to vertical, it is making theta angle. So this is x, means what the distance from the main position, from this position to the, okay, I will draw the diagram once again so that we can understand easily. So this is the way the two spheres are separated. The separation between these two is how much? X is given from the equilibrium position. So it makes an angle theta here. And here you need to understand there is a electrostatic force of repulsion will be there like this. Mg will be there like this. This is the common forces which are acting, and there is a tension in the string also, right? Next. So from the geometry, we can find the required answers for here. So here tension is resolved into components, we can make it, okay. If you resolve into components according to the concept of the triangle, if you use this triangle, from this triangle, what I can write, tan theta is almost equal to sine theta we taken in the previous concept, you can check it, is equal to, okay, tan theta equal to sine theta almost is equal to, according to formula, what I can write, electrostatic force by mg we can write. This is a formula we can write. So what is sine theta here? From the, okay, triangle, from this triangle, sine theta nothing but opposite by hypotenuse. So what is opposite? Opposite is x by 2, because from center to center this length is equal to nothing but we can write as x by 2 is the length of this one from here to here. L is the length of this one. So opposite is x by 2, hypotenuse is L. So x by 2L is the sine theta value we can write. So x by 2L is equal to Fe by mg. What is Fe? That is nothing but we can write as formula as 1 by 4 pi epsilon naught into charge. Both are having same charge, Q and Q. So this Q and Q I can write as Q square by square of the distance between them. What is the distance between both the charges? That is x square. So that is the electrostatic force between the two charges by mg. What is mg? Weight of the body. That is nothing but we can write as mg. Because in the answers, if you see that the answer is in the terms of mg, so no need to convert in this. So here our requirement is to find the x square relation dq by dt. So first find the q square value. So if you solve this one, I want q square value. So keep this q square here, remaining everything is make it this side. That means q square is equal to what I can write? Q square is equal to this q square is equal to, if you keep it here, x into mg into 4 pi epsilon naught x square by 2 into L I can write. And here we have to understand here there is a x square. Total becomes x cube it becomes. I can write the relation. Okay, in terms of q is equal to, I can write in terms of whole power, right? Like this is becomes x cube into this 2 times I can cancel here. That means I can write as 2 pi epsilon naught mg by L I can write, right? So this is whole power 1 by 2 I. So whole power 1 by 2 q value, because square if you make it that side becomes 2. So if you write in this one, q is equal to what I can write, x power 3 by 2, and the remaining everything is you write in the form of root, that is 2 pi epsilon naught mg by L according to the given question. Check it this one. Now what is changes? Q. The Q is, if you observe this one, the Q is changes with respect to time because it is leaking out. The charge is leaking out. So this Q value is leaking out means you have to differentiate this one with respect to time. dq by dt. If you differentiate this one, x value also changes because the distance between these two is x. When both the spheres are coming towards each other, okay, with the speed, then what is happening? The x value also decreasing. Okay, so x is also varies as the charge is leaking out. X value changes. As x value changes with respect to time, they gains the velocity. So the velocity relation is given. So I can differentiate this equation. In this case, x is only the variable. I can write as 3 by 2 into, I can write as, okay, x power 3 by 2 into, that is x power 3 by 2 minus 1, because n into x power n minus 1 differentiation formula. 3 by 2, that is nothing but again we are going to get 1 by 2 into x, if you differentiate, that is dx by dt. So anyway, this is not having differentiation, you can keep it like that, that is 2 pi epsilon naught mg by L unit. So here what is dx by dt? Rate of change of displacement, nothing but velocity. Now what is the velocity relation given in the question? That is x power minus 1 by 2. Here already we have a plus 1 by 2. Dx by dt is x power minus 1 by 2. Both will get cancelled. If you, okay, after getting cancelled, what is the relation you are going to get? dq by dt is equal to nothing but 3 by 2 times of remaining relation, that is under root of 2 pi epsilon naught mg by L unit. So if you compare this equation with the given standard equation of our question, okay, dq by dt is equal to, what is given? This is dq by dt is equal to, in the place of n, what we have? In the place of n, what we have? In the place of n, what we have? 3. We have 3. So n is equal to 3. In the place of 2, we have a 2. Remaining everything is same. So what is n value? N is equal to 3. So this is the way you can solve the problems like this. Concept is, main concept is at equilibrium condition, tan theta form we are going to use, and this theta is very small based on that sin theta concept we are using. And while charges are, okay, leaking out, that's why what is happens, attraction force decreases, so they are coming towards each other, x value changes. As x value changes with respect to time, velocity takes place. The velocity relation already given, substitute that velocity in the equation to get the desired, okay, numerical value. Yeah, so n value is equal to how much? That is 3 is the answer. This is one more okay, mains levels concept, and IIT mains and advanced level also they ask the questions on this one. What the question is given is 2 positive charges plus q fixed on x-axis at position plus d and minus d position. A third charge plus q of mass m displaced from the origin. This is given. So first we have to take the diagram of this one. So here we taken x-axis. So on this is the origin. If you say from the origin, we taken one charge here, that is charge, okay, taken as plus q, and we taken one more charge here, that is also plus q. One is at a position of plus d comma 0 along only x-axis. Second charge is at minus d comma 0. This is the origin. At this origin we placed what charge? That is plus small q charge we placed here. This is given. And a small displacement s is less than d is given. Now the distance, what is d here? D is the distance of that, right? D is the distance. Now we given a small displacement. So this charge we displace from here to here, if you say a small displacement called as x, if you given, what happens? A small displacement x is given onto this one, then releases from the rest. Then what happens? They given 4 options in that. What are the options which are suitable for the answer? We can check it. So whenever the charge is displaced from this position to this position, that is here. So what happens now? This charge will becomes more distance from the first one, that is left side one, and it becomes near to the right side one. So the distance between the charges will become changes. Now if you observe the diagram, so this is the origin and this is the actual plus q charge. Now after displacement of that q, this is the new position of the q from the origin. It is displaced from the origin. Now what is the distance from this charge? From this plus q, what is the distance of that one? This is the distance of this. This distance is nothing but already we given. The distance is, this is minus d. This is the, that minus indicates the direction only. So this is the distance d from here to here, and this is the displacement x which you given. So the total distance is the d plus x. Now similarly for the second charge, this is second charge. For the second charge, what is the distance? Okay, d is the distance between distance of the plus q. But when the charge is moved towards the charge plus q, now the distance between two charges will become so much? D minus x, remaining charge. So one case the distance is increased, one case the distance is decreased. So in the case of decreasing distance, force will be more, yes or no? Because according to concept of force between the two charges is equal to, we can write as k, I am writing constant 1 by 4 pi epsilon naught, I am taking as constant k, into product of the two charges. One is capital Q, one is small q, by square of the distance between them, square of the distance between them. In this case, one distance is d minus x whole square, one force if you say, and another force is nothing but we can write as, okay, this is I am writing as F1, F2. Another force is F2 if we taken, that is k into capital Q small q by d plus x whole square, because the distance is modified. Now force is inversely to the distance, square of the distance, right? So in this case, if the distance between the two charges is less, in this case d minus x means actual distance is decreased. Decrease means force will be increased. So F1 force is more than F2 force. The force between these two is more. So force between these two is more means what is happens? This q repels more, and that means this capital Q repels more towards the left, and there is a repulsion force towards the right. Okay, the left side q, this one applies the force towards the right, and this one applies the force towards the left. Which is force more? This is I'm writing as F1, and this I'm writing as F2. So in this case, F1 is more than F2. Simple. Now these two forces are acting on the charge, so you take the net force. So net force is equal to nothing but F1 minus F2. Now our requirement is to find the solution of these two. So F1 minus F2 means what I can write here? F1 minus F2. So what is F1? Take the common terms. K is common for the both. Capital Q, small q also common. So if you taken, now this becomes what you are going to get, 1 by, that is d minus x whole square. F1 force is more by 1 plus by d plus x whole square. Now solve this one to get the resultant, that is k into q into, I can write as this is d plus x whole square minus d minus x whole square. Okay, total divided by, that is d minus x whole square into d plus x whole square. Now if you observe this one denominator terms, if you solve it, it is in the form of a plus b whole square, it is in the form of a minus b whole square. So if you solve this one, f net is equal to, I can write as f net is equal to, that is k into capital Q small q into, so what I can write here, d plus x, that is nothing but d square plus x square plus 2dx minus, that is d square minus x square plus 2dx unit, total divided by, this is a minus b whole square, a plus b whole square, I can write as a square minus b square, like I can write as d square minus x square whole square, a plus b into a minus b is equal to a square minus b square, I can write as whole square, like. So if you solve this one, in this case, what is the cancellation in the denominator? So you can see here, plus x square minus x square plus d square minus d square get cancelled. So remaining terms I can write as net force equal to, what I can write, that is k capital Q small q, denominator 2dx plus 2dx, that is totally is equal to 4dx by, okay, in the denominator we have d square plus x square whole square, d square minus x square. Okay. Now this is the net force you got. So according to condition, if you see this one, x is, what is s? S is the less than t. Here I taken as x. They given in the question s. Okay. So that s is, that means in this case I taken as, you take this one as x. So x. So x is less than t, means the x value is negligible. You can take it as 0. If you taken this value is equal to 0, what you are going to get, net force equal to, compared to d, that is k into capital Q small q 4 d into x by, that is d power 4 e. So in this case, numerator 1d, denominator cancel, that is dq we are going to get. So this is a relation, one of the relation you are going to get, net force equal to nothing but we got as, okay, 4k q small q by dq we got. This is one of the most important relation you have to keep in mind. So finally we got f net is equal to 4k capital Q small q x by dq we got. And if you see the, okay, question, what is the question is given? The question is given based on particle will execute SHM. If the t is the time period of oscillation, then t square is proportional to dq. Motion of the particle periodic and simple harmonic. Particle comes quickly, rest, and after when released. Means if you see the terms, all terms related to simple harmonic motion. So whenever you observe the simple harmonic motion terms, in this case you have to, okay, go for the simple harmonic based concept. So whenever the simple harmonic motion taking place, there is a certain forces required to oscillate a particular body, right? So here the net force which is created on the charge, that creates a oscillation of the charge, that is the meaning of this one. In this case, net force equal to mass into acceleration, I could write ma is equal to, that is 4 into k capital Q small q x by dq by. So acceleration a is equal to, I can write as 4k capital Q small q x by, okay, that is nothing but m into dq we can write this relation. Now what is acceleration? Because time period based given, acceleration is equal to, we can write as omega square x. Okay, omega square is x equal to 4k q small q x by m into dq we can write. So here this x get cancelled. After cancellation of that x, what the relation we got, omega square is equal to, so omega square is equal to nothing but 4k capital Q small q by m dq we got. So from this, what is omega? Omega is equal to under root of, that is 4k capital Q small q by n dq we got. This relation we got, right? Now if you want to write time period in terms of time period, what is omega? Omega nothing but 2 pi by t. So 2 pi by t value is equal to under root of, that is 4k capital Q small q by m into dq we can write. And what is time period? Time period is equal to 2 pi under root of, that is I can write as m dq by 4k into capital Q small q. This is the one of the formula we can write. Now if you want to write more different ways of this answer, T is equal to, that is 2 pi under root of m into d cube by, so that capital K, so what is this K? 1 by 4 pi epsilon naught. What is this K? 1 by, that is 4 into, I can write 1 by 4 pi epsilon naught into capital Q into small q. So in this case, this 4 get cancelled. So now I can write this answer also in the form of 2 pi under root of m into d cube by, okay. So what is left here, that is capital Q small q. Denominator pi epsilon will go to the numerator. So that means it becomes pi epsilon. So the answer for the question may be in this form. You have to check that T is equal to 2 pi under root of m d cube pi epsilon naught by q cube. So here relation, the T, if you come across T, this T is directly proportional to under root of d cube relation. So squaring on both sides, I can write T square is proportional to d cube, I can write. So check the options. According to that one, we can decide. Before that, here we take an acceleration. According to acceleration omega square x, this is also in the form of omega square x, because this is, we compared as omega x. So it is giving the condition of SHM. If any particle is under the SHM condition, it has to, the acceleration must be opposite to displacement. So here also it is giving acceleration is related to displacement. So if you see the options of this question, what is given? First option, particle will execute SHM. Particle will execute SHM. So this is the one of the condition we can say, correct. Particle will execute SHM because length is very small, so it is performing oscillation, so it is correct. Second one, if T is the time period of oscillation, T square is proportional to d cube. Just before we got T square is proportional to d cube. So according to the answers, what are the answers we can write? The answer for the question is, first one is correct, second one also correct. Motion of the particle is periodic but not simple harmonic. No. Here in this case, what is happens, if the displacements are large, then it may be periodic, not simple harmonic. But here the displacement is very small. So in this case, the oscillations both the sides from the origin is very small. That's why it is always a simple harmonic based. We can take it as, okay, it is not the condition that it based on a condition of oscillation. But here we are taking x is very small. Small oscillations always a straight line oscillation. Always it is a SHM. Next, last one, particle comes quickly, rest at the origin when released. Immediately means no, it takes a little time for to come to rest until unless there is no external frictions are taking place. So C and D, compared to that, A, B is the correct answer for this question. So this is a way you have to find the answers for the question. This is most important one question, you have to keep it in mind. Now this is the one of the question related to electrostatics, electrostatics force concept. And a vector based question they previously asked in the one of the AEEE question they asked in this fashion. So we'll discuss on this one. The given three charges are placed as shown in the figure. We have three charges. One is Q1, that is negative charge minus Q1. Second one is Q2. Third one is Q3, that is a negative charge. One positive, two negative charges as we are looking, they arranged. So according to the coordinate system x and y, the Q1 is at the origin and the Q2 is along x-axis, Q3 is making an angle theta with the vertical, that is y-axis, as you are looking here. The distance of the Q1 is at origin, Q2 is a distance of B from the origin, and Q3 is a distance of A from the origin. So what they're asking, the component of force, you can see the question, the component of force on the minus Q1 R. Which is the minus Q1, this is the minus Q1. What are the forces acting on that one in terms of component unit? So here, to get the in terms of component, our requirement condition is here, how many ways the forces are acting, we need to identify that. So to identify the way of forces, how many ways the forces are acting, first, minus Q, So what is the force acting on the minus Q2? Check that one first, Q2. Q2 is positive charge, Q1 is negative, both attract each other. So the minus Q1 is attracted by Q2. What direction? This is the direction this is going to be attracted. This is the force. That force I am writing as F2, force due to second charge. Next, what is Q3? Q3 also applies the force on this one, but both are okay negative. Negative means repulse each other, so the Q3 will repulse this one in this direction. So this force of repulsion I am writing as F3 because both are opposite. These are the two forces mainly you can see on minus Q1, component of forces on minus Q1. So if you observe this one geometrically, okay, so here this is the coordinate system I am choosing here. This is the coordinate system y-axis, and this is the coordinate system I am taking x-axis like this. So with respect to Q3, make an angle theta with respect to vertical. So according to geometry, I can take this angle also theta. So F3 is the force. I can resolve the force into components. I can resolve the force into components. If you resolve into force into component, what you are going to get? That is equal to F3 cos theta. You are going to get one component. Other component you are going to get in the direction of the x-axis. This is the way we are going to get one more component. That component is equal to F3 sine theta. You are going to get F3 sine theta. These are the two components we have for F3. Next, F2 anyway along x-axis. Now any other forces are acting along y-axis means no. Now you come across here. So force acting on the which one? Force acting on minus Q1. This is there is a component base means Fx, force along x-axis in terms of Fx I cap. Nothing but we can write in terms of we can write in terms of that is Fx plus Fy, where Fx and Fy is called as components. I can write as in terms of mod F into I cap plus mod F into J cap. We can write. So here, what is Fx along x-axis? We have what are the forces we have along x-axis? What are the forces we have along x-axis? The forces along x-axis we have two forces. F2 is there, F3 causes. So I can write simply F2 plus F3 sine theta. Both are acting in the same direction. We can add it directly. This is along x-axis. Now you can write this. What is F2 formula? F2 formula is equal to force between the minus Q1 and plus Q2. Okay, so the force of repulsion between these two is equal to what is the formula? 1 by 4 pi epsilon naught. Okay, epsilon naught. The charge is, what is the charge? That is nothing but one charge is minus Q1 plus Q2 by r square. R square means square of the distance. What is the distance here? That is b. So we can write as b square plus F3. What is F3? Force between third and this. So anyway, that becomes minus of minus 1 by 4 pi epsilon naught minus Q3 minus Q1, that is nothing but Q1 Q3 by distance between them is a, that is a square, into we have a sine theta, so we can write it as sine theta. This is in terms of magnitude line. If you want to write in terms of components, you can write as into I cap. This is the force along x-axis. If you see the options, what are the way the options are given? If you check it, first option, if you see that k, what is k here? 1 by 4 pi epsilon naught, they taken as k. So we will also write in the form of that Fx equal to, this is k, I am taking common. If you taken common like that, so what I can write here, this is anyway attraction force they given, that is nothing but Q1 Q2 by b square plus second one is Q1 Q3 by a square sine theta I cap. Check the option first one, k into Q1 Q2 by b square plus Q1 Q3 by a square into sine theta I cap. This is similar to this. Remaining second option, Q1 Q2 by b square, Q1 Q3 by a square, but there is no sine theta here, but we have a sine theta there. So second option is not correct. And third option, if you see, cos theta is there, but we have a sine theta component is there along x-axis, because x component is, x unit vector is I component. So in this case, we have no sine and cos, so this option not. So what is the x component of this one? That is nothing but Fx equal to this is the x component of that. Similarly, what is y component of this? We can also find the y component. So what is the y component? Y component of this force equal to nothing but we have only one y component, that is F3 cos 30. F3 cos 30 is only one. F3 cos 30. What direction it is? That is negative. Y axis, that is nothing but minus, we can write negative. So I can write that is equal to minus k into 1 by 4 pi epsilon naught, I taken as k, two charges q1, q3 by, okay, what is the distance? A square into cos theta, not 30 degrees, sorry, that is we taken as cos theta here, not 30 degrees. We did not given any theta values here, right? That is cos theta, here also cos theta into j cap theta. So Fy. So force along y-axis is equal to how much you got? That is minus k q1 q3 by a square cos theta into j cap. This is the answer. So which option is correct? You can check it. This is the first option. So answer first option is correct for this question.